So the big pain points, metadata management, right? It's a big pain point. I talked a lot about it throughout the presentation. In a data lake, it's manual, heavy lifting, hard to do. You got to write code on your own to do all this stuff. On the Lakehouse, again, it's still manual. There's an abstraction, so it's easier. You don't have to write your own code, but you do need to know when to run it, how frequently to run it, if you should schedule it or not, if it failed or didn't fail. There's still some cognitive load that you need to manage. When you write the data into the storage, like I said before, file format and the way data is stored makes a big difference to your ability to get the best performance. So if you're not thinking about how data gets stored, you're going to hurt yourself when you try to query the data. On a data lake, again, it's manual, heavy lifting. You need to write code to do all that optimization, compaction, deletes, retention, sorting, clustering. It's very error prone. It tends to fail. I've seen these fail so many times, and people get stuck in this rat nest. A lot of times it's painful. Lakehouse tries to abstract it. Again, it offers a lot of these capabilities out of the box, but the cognitive load shifts to the end user, to the analyst, who says, okay, now I have a table, doesn't feel very good. I need to go run an optimization thing on it. What if you didn't delete all the data properly because you forgot to write a pruning? I forgot to prune the table. Now you got GDPR compliance risks, right? You have to keep maintaining it. This copy on write, merge on read thing. Here we go. It's coming back again, right? Why do I need to think about it? So it's still some of the pain that you got to deal with in a Lakehouse. On the read side, when you're querying the data, very similar. The querying performance actually comes from the querying engine, right? But it is dependent on the data. So it's inconsistent and engine specific on the data lake because it's heavily dependent on the behavior of the behavior of the engine with the physical files. The Lakehouse is a bit more predictable because we have a standard table specification that describes how data should be laid out and how users or engines should interact with it. And then lastly, around stream ingestion, Lakehouses aren't really designed for that. They're still designed very much for batch workloads where you kind of merge all the changes at once. But in the streaming world, like change data capture, log analytics, security analytics, application analytics, like those require streaming changes. So we need to make that better, right? But those changes currently are not efficient in the Lakehouse, and they're eventually consistent. So you'll eventually see the result, just not what you want at the moment that you want.